All right, so we were on talking about the Jovian planets, or also known as the gas giants. Um, all right, so here are some tendencies. They're much larger than the terrestrial worlds. They tend to be very low density. That is the density. Remember, for the Earth or the terrestrial worlds, it's around the density of 5 grams per cubic centimeter. These tend to have a density of less than 2 grams per cubic centimeter. All right, so around there. Um, I mean, it varies from which planet you're talking about, but it's usually less than 2. All right, so they're much larger than the Earth, and they're much wider. They're spaced apart from each other, much greater. All right, so Jupiter is just on the other side of the asteroid belt. Um, and in fact, that's probably why the asteroid belt is where it is, by the way, is because of Jupiter. Jupiter is by far the most massive. So, you could add up all the masses of all the other planets, so including the gas giants, and you still would not be at the mass of Jupiter. So, Jupiter really is the king of the planets, as it were. Um, but its gravitation influences the outer part of the solar system enormously. All right, so this is of course, and I think I mentioned this already in an earlier video, that Uranus and Neptune are actually technically not gas giants; they're considered ice giants. All right, so and Neptune is slightly smaller than Uranus, although it's greater density, it turns out. But that's a little bit more detail than we need. All right, so Jupiter is the first of the outer planets. It is more than 11 times the diameter of the Earth, um, and it is, of course, the biggest. Um, it's composed mostly of hydrogen and helium, although there's other stuff in the atmosphere, namely ammonia and methane as well. It has these bands of these. Let's see, do we have a picture? There it is. So it has these bands. Even with a small telescope, you can see these bands. These are the upper clouds. So this is the thing about the gas giants is, and this is the main difference between the gas giants and the terrestrial worlds. There's no surface, right? So you're just getting you go if you were to plunge a spacecraft into Jupiter, and by the way, we've done that in a long time ago. And so all it is you're getting thicker and thicker clouds as you get towards the center of Jupiter. Now, right at the center of Jupiter, or really close to the center, we estimate that there is some solid material, and possibly metallic hydrogen, because the pressure is so great. And one of the spacecraft, so we've sent several spacecraft to orbit Jupiter. One of them, for more than 10 years, was called the Galileo spacecraft, named, of course, after Galileo. And Galileo, the Galileo spacecraft orbited Jupiter for more than 10 years, gave us tremendous amounts of information about Jupiter. Right now, as the making of this video, there is another spacecraft called Juno, which is just another name for Jupiter. The Juno spacecraft is actually orbiting this way, in a north-south. Let me redo that a little bit. So it orbits. It gets really close to the north and south poles, but when it in its orbit, it takes it really far away from Jupiter, and then it comes really close to the north or the south pole. And so the purpose of Juno was to actually investigate the North and South Pole, and also to try to figure out what's at the center of Jupiter, right? That was the big thing. Let's see, the atmospheric pressure is more than 1 million times that of the Earth. The Huygens, sorry, not the probe that we sent into, oops, I'm going the wrong way, that we sent into the atmosphere, measured some of the pressure in the upper atmosphere. Another feature that you can see, and Galileo, in fact, was the first one to notice this by looking in the year 1609, late 1609. He looked at the different. He had taken his telescope, his very primitive telescope, and looked up at the night sky. And one of the things that he found was there were these four bright objects that changed position night after night, and just basically these were moons that were orbiting Jupiter. And here are two of them right here. There's one right here. There's another one right there. So this is the order of them. They're not showing. Let's see. Yeah. Oh, there. Here's the order of them. So this one right here is called Io. Io turns out to be the most volcanically active object in the solar system. This one right here, this one to the right hand side is called Europa. Europa is of great interest to us because it seems to have an incredible ocean of salt water inside of it, and in fact has more water than all the oceans on the Earth combined. So that there's another, and this again, when we get to the outer parts of the solar system, we look for we are interested in the possibility of microbial life living, not on the planet, right? Not on Jupiter, of course, but maybe on the moons, right? Let me cover the rest of this, just before I get to this next thing about the moons. So the atmosphere is roughly, it's mostly hydrogen. There's helium, there's methane and ammonia, and that's where it gets all of its color, or a lot of its color, I should say. There's no surface. There may be an iron, nickel core, or other minerals at the center of Jupiter. Again, that's what the Juno spacecraft is trying to investigate. So how long does it take Jupiter to orbit, what would be one day on Jupiter? And really, it's hard to say. What we've generally done is we use, probably the biggest cloud formation, of course, is the Great Red Spot, which, by the way, is a giant cyclone, or anticyclone technically. Anyhow, this storm has been raging for at least 350 years, perhaps a lot longer. The reason I say 350 years is we know from historical information about people looking at Jupiter with telescopes. After the time of Galileo, lots and lots of people investigated Jupiter, and of course found this noticed this Great Red Spot. In recent times, however, the Great Red Spot seems to be getting smaller. We don't know that the storm is going to last forever, but it's been there for at least 350 years. Who knows how much longer? All right, so let's get to the moon. Oops, so I just did that. All right, so the moons. All right, so I just mentioned this one right here. This kind of orange one is called Io. Io is the most volcanically active object in the entire solar system. There are constantly volcanoes going on, erupting. At any given time, that there are probably a dozen volcanoes that are erupting. We've witnessed this over and over and over again. This is this one right here, the smaller one, is called Europa, and it has a gigantic liquid ocean, underneath the frozen surface. This really large one is the largest moon in the entire solar system. It's called Ganymede. It also contains we think some liquid water underneath the surface. And this one right here, this dark one and extremely heavily cratered, is called Callisto. All right, so Io, Europa, Ganymede, and then Callisto. I don't know why they put them in this. So that's the order from Jupiter, right? So Io is the nearest one. The nearest, by the way, these four are the largest moons of Jupiter. Remember, I mentioned before there's more than 65, probably more than 70 right now, confirmed moons of Jupiter. At any rate, most of the ones that have been recently found are really, really tiny, and so it starts to become a question of, are these things actually moons or not? But these are the first four that were discovered: Io, Europa, Ganymede, and then Callisto, in that order from distance from Jupiter. So, and there's actually another group of moons that are much smaller than these, that are closer to Jupiter than these. These are kind of the middle, the moons that are in the four middle ones, and then the inner ones are rather tiny, and then the outer ones are really, really tiny. All right, so these are interesting worlds in and of themselves. Let's see what else. So this is there's Europa. Once we got a really good look at Europa with spacecraft, people remarked or noticed right away that the surface was extremely young. All right, so here's a big idea that has to do with the entire solar system. The entire solar system. The more cratered an object is, the older it is, right? So Callisto right here is extremely heavily cratered. So we don't think that there's nothing that has changed the surface of Callisto for a very, very long time. Whereas if you look at Europa, it's extremely young. There's hardly any craters at all on Europa. And of course, Io right here is constantly changing its surface because, there's volcanic activity going on all the time. And so it's constant, this one doesn't, this one is just changing its own surface. But this one, of course, is, Europa is changing its surface, because it's this frozen water. All right. So this is the nice picture of Europa, or at least what we think. There is been some talk in NASA circles of someday sending a spacecraft to Europa and somehow burrowing down beneath the ice and possibly having this spacecraft, or the probe really, burrowing, digging down through the ice somehow. We don't know how that's gonna, and we don't really even know how thick this ice is. But if we could, we dig through it and then swim around in this gigantic ocean that makes up most of Europa. All right, so and again, this is more liquid water than if you added up all the oceans on the Earth. And this is a moon. This is just a moon of Jupiter. All right, and that's not the only place that besides, of course, Ganymede also has some liquid water. Then we come to Saturn. Okay, so Saturn, of course, is its most famous because of its ring system, which is icy particles. And by the way, I should mention this as well. The rings of Saturn are, they cannot form a moon. All right, so let me go over this a little bit, and I did mention this in an earlier class, what's called the Roche limit. All right, so If you take a moon